going to learn how to factor out the greatest common factor. To factor out the greatest common factor, there are two steps. The first step is to identify the greatest common factor. That is the term or the expression that will divide each of the terms evenly. And then we will divide each term in the polynomial by the greatest common factor. For example, if we start with the expression 5a squared plus 20a, we may be asked to factor out the greatest common factor. So we want to follow these two steps. First, we need to identify the greatest common factor. That is, what expression would divide or is in common with both of these terms. What do you think, Mr. Portier?
5.
5 is a common factor, but it's not the greatest common factor because it also shares a common variable.
Oh, A.
A. So the greatest common factor would be the expression 5a. So we identified the greatest common factor, and then we'll divide each term by the greatest common factor. So 5a squared divided by 5a would leave us with, what do you think, Mr. Journay?
A.
A. And then positive 28 divided by 5a would leave us with the second term. What do you think, Mr. Stiggy?
4.
4. Positive 4. And we can check our answer by using the distributive property. 5a times a would give us 5a squared. 5a times positive 4 will give us positive 28. So here we have factored out the greatest common factor. In the second example, we have the expression 15x squared y plus 21xy squared, and we want to factor out the greatest common factor. So remember, there are two steps. We first need to know what is the greatest common factor between the expressions. And then we'll divide each term by the greatest common factor. So for the expression 15x squared y plus 21xy squared, what do you think the greatest common factor would be? Class?
3, x, and a y?
15 and 21 are both divisible by 3. And then we have common variables. Both terms share a common x and a common y. So the greatest common factor would indeed be 3xy. So we first identify the greatest common factor. And then we want to factor out the greatest common factor. So we divide each term by the greatest common factor. So 15x squared y divided by 3xy would leave me with 5x. And then the second term, 21xy squared divided by 3xy would give me 7y. And as always, we can use the distributive property to check our answer. 3xy times 5x, 3 times 5 is 15, x times x is x squared, times y. So 15x squared y plus 3 times 7 is 21, x, and y times y is y squared. So our final answer, when we factored out the greatest common factor, 3xy times 5x plus 7y. We're factoring out the greatest common factor, and we saw in our previous examples that meant identifying the greatest common factor and then dividing each term by that greatest common factor. But in this expression, in this example, we have negative x minus 5. And it may not be easy to see or understand what the greatest common factor is here because negative 1 is the coefficient of x, and the constant is negative 5. Well, 5 is a prime number. What can we do to this expression? Do we say that it's factored out, or can we factor something out?
Can you factor a 1?
We can factor out 1, but a 1 would not change anything. What would happen, or what could we factor out in order to change the expression?
Negative.
-1. If we divide each term by -1, then it will change the sign of each term. So in this case, our greatest common factor would be -1. And remember, once we identify the greatest common factor, we divide each term by that greatest common factor. So -x divided by -1 would give me
X.
positive x. Negative over negative makes positive. And then -5 divided by -1 would give me
Positive 5.
positive 5. Absolutely. Factoring out -1 will change the sign of each term. And again, we can check by using the distributive property. -1 times x is -x. -1 times positive 5 is -5. So we factored out the greatest common factor. We've been factoring out the greatest common factor, and in each of our examples we've seen that we identify the greatest common factor and then we divide each term by the greatest common factor. In this example, it's going to be a little bit different in identifying the greatest common factor. Let's take a look at the example. Here we have the expression 3x times x plus 5 plus 4 times x plus 5. In this expression, we want to identify the greatest common factor, but it looks a little bit different because the expression x plus 5 is a binomial. But notice, it really follows the same pattern because each term has that common binomial. So the binomial x plus 5 is the greatest common factor. So we identify the greatest common factor x plus 5, and now all we have left to do is to divide each term by that binomial. So the term 3x times x plus 5 is divided by x plus 5, and that leaves us with the term 3x. Finally, the term 4 times x plus 5 is divided by the greatest common factor x plus 5, and that leaves us with the term positive 4. So again, we have factored out the greatest common factor by identifying the greatest common factor and dividing each term by that greatest common factor.